substitute speaker here about building open source with open source. It's quite a bit, of course. I'm from the Pache Bigt project, which is building the Hadoop open source ecosystem with open source means. So the first slide is from my talk from Budapest ApacheCon October last year. I recycled almost all that talk. Sorry, I had no time to prepare, but I'm filling now some background information about the Pache Bigt project first. The Bigt project is some kind of melting pot for all the tools and projects within the big data world, most of often the Pache projects. We are building it, we're integrating it, we are deploying it, and we're testing it. That's some kind of the roadmap. What it is. It was started by Roman, sitting there, and I think, how many years ago?
2012.
2012, and now we had at ApacheCon we had the version 1.0. We're now slowly or fast approaching version 1.01. Hopefully in a few weeks or what's interesting about it, we are building it with Docker CI Jenkins environment. And in order to give you a glimpse of what we're really including, that's the axis of the operating systems from CentOS, Fedora, Ubuntu, Debian, OpenSUSE, and that's all the packages we are supplying. That's from Hadoop, HBase, Hive, the user interfaces, alternative file systems, machine learning tools like Mahu and Spark, and data ingest like Swoop, Tapion as an accelerator, Tess as an accelerator, YCSB as a benchmarking tool, Zookeeper as a coordinator, and Zeppelin as a UI for instance for Spark, and some other stuff I do not know about. And we do not only build it for Intel x68, we are building it right now for the PowerPC 64-bit little Endian 2. There's some failures here. That's because these packages contain in the build chain Node.js code, and Node.js isn't supported on that platform and that release. So we have to fix it out somehow. And all the artifacts are built on Docker, and the Docker receipts build files are open source, of course. And these are for instance, the Docker Hub images we are pulling in order to compile. So you see here that's for the different versions of operating systems. You see here the images, and here is even the image for the PowerPC. So that's I wanted to talk about today. So I'm proceeding to my original talk. It's about how to build on that a deployment which is secure and highly available. And about the company and me, I'm active in open source for over 20 years. I contributed to the master libraries of Linux back in the years of version 5. Was a developer, ported Python to the Xeon 5. Contributions to Flight Gear Simulator, and I'm a maintainer of a Kerberos utility. My company is a system integrator for HPC, so I'm coming from the HPC business doing big data right now. The target scenario for our customer was to build a secure, reliable, Debian-based Hadoop system for the Federal Office of Information Security in Germany. And the cornerstones we had to use Greenfield, Kerberos, LDAP, Debian, Jessie, that was the not stable at that time, Zookeeper, HA, Hadoop, Hive, U, with automation because it's a cluster, and we like to upstream all of our work to the repositories. And we need an offline installation. That's an important thing, because most of the some of the commercial distributions at that time had only an online installations. The work we done, we donated to the Big Top project, so almost everything you're seeing here is now right in the repositories, but we had a long way to push it upstream. And that's the automation I'm talking right now. This is not completely upstream. We are using the experiences we had with HPC clusters, large clusters, in order to automate the installation of Hadoop. And we did it with Puppet, both because GitHub already had some Puppet receipts, and we built on that to do in power deployment automation. In order to explain what you have to do in order to get a secure setup, you have to do an MIT Kerberos server, master slave setup, installation of the KDCs, you have to configure the replication, you have to manage the host and service principals, and you have to manage the key types. And if you're looking hard at it, you have a lot of automation to do, like time services, monitoring, databases, hosting resolution, authentication, firewalls, locales configuration, authentication, manage host keys, time zones, and to configure the tools is only a small part of the infrastructure we have to do. Most work is in the infrastructure behind. So we did it with Puppet. Puppet, not everyone may know what Puppet really is. The ecosystem of Puppet contains the engine, some factors, determines the fact of the system itself, has some hierarchical database, and OGIAS is a thing to manage snips, labs, and code we have placed into the configuration files, and PuppetDB is something that can consume all the facts of the cluster and push it to the cluster again. For instance, it's needed for managing the SSH host keys. You know, if you log into the first time into a system, you will we ask whether the host key is valid. That one can be automated by the Puppet, pushing it all to the PuppetDB and deploying to all the clusters. This is done by Puppet Manifest. I will skip that. And that's important. There are two different modes with Puppet. A masterless or apply mode. That's one. I say I want to configure that node with a command. I say Puppet apply, and it's pushed onto the configuration. The Puppet master mode, the agent mode, is that the agent continuously pulling in the configuration and applying it locally. And it has the advantage if something is broken, it will be fixed by Puppet afterwards. Or to say the other way around, if you're trying to fix it manually by hand, you are fixing a configuration file, then Puppet will change it again. So you have to do it at the master. The Puppet recipes by BigTop are in the masterless mode, and we reuse the BigTop recipes into doing a master configuration. That has the advantage the Puppet configures creates a PKA, a Puppet key infrastructure. So it generates a certificate and trust between the clients and the master. And for almost everything there is a PKA necessary. And the trick we use is to reuse the Puppet CA for all the trust within the cluster. So no manage and the advantage is Puppet does create the CA without manual intervention. So it creates a trust between the agent and the master, and one has to say yes, that's the correct master, but that's all. And we can automate everything if we can have an initial trust between the master and the client, and every SSL certificate and every Kerberos credential is transported securely without manual intervention between the different nodes of the system. And we thought that is cool, and we automated this from button to all the from the top to the bottom. So that's a typical use case how to use Puppet. One is looking for in Puppet Forge for modules, try that out, install it, and use it. And we had already some configuration files in Puppet. So some slides ago I showed what we all have to do, and that's all the what we have done with Puppet, because almost all was already there. So we reused all these things which were already in place with the open source. We had some problems with the Kerberos, because the Kerberos BigTop module was only suitable for testing. It was an unsecure Kerberos setup. So we found a suitable Kerberos module within Puppet, and did a wrapper around it that is compatible to the BigTop one. And now we can plug in that module into the BigTop module, and you can do a secure Kerberos rollout. That's a work which was done by a colleague of mine. It was a co-presenter in Budapest. That's, I have to shorten it. It's about the, that's the bootstrapping of Kerberos with an certificate. That's the key point about bootstrapping with the CA. That's a PK init extension of Kerberos. It's a little bit advanced. And you have, that's out of date now. So we use the Puppet CA for the PK init. And now we enhance the BigTop templates that's already in place, supported journaling, HA name nodes, that's all the stuff one needs to a highly available Hadoop infrastructure, putting up a highly available resource manager, configuring the Hive and the user interface, and securing it with all the Kerberos infrastructure. So there's something special about the Kerberos infrastructure we need with Hadoop. The principles are not only known as called service, they are called service/hostname or fully qualified domain name. And this is a little bit a trick to work around some Kerberos problems, but that have to be done in that work. The authentication is in order. The authorization, we found some problem, the yes, that's, I can skip. But in Zookeeper we had a problem. We found a problem that the authentication is done by Kerberos. That's okay, but the authorization has a problem because we have access controllers in Zookeeper to order to protect the semaphores, and these semaphores are unprotected. So everyone can delete it and can the open source was a hobby project before, and this was a great experience to work with the communities to fix all the stuff in order to get it that running that way that we can deliver it to the customer. With fully open source, you can pull it from the repositories and build all the stuff. My original talk I wanted to present here, but was rejected, was about rolling your own Hadoop distribution with all the contents in the repositories. So I couldn't give this presentation, but I have a short introduction. What is possible with Apache Bigt, getting all the stuff from different repositories together and put a fully blown, secure installation, big data installation. Thanks.
Plenty of time for questions.
How did you manage to have high availability for the Hadoop name node, and what did you use for that?
The Hadoop highly available is built out of Zookeeper. It manages the journal. First contents is the journaling. You have journaling on each name node. This is replicated between the, and then you have a quorum manager, and you have to have an odd number of quorum managers coordinated by Zookeeper, and this, together with the journaling, you have then HA Hadoop file system. That's the first thing. The other thing, you need a highly available resource manager, so you can run the jobs and switch on between. That is the highly available resource manager. That's built into Yarn 2.6, I think, contained it, and 2.7 it actually works.
Now, I was actually curious about the fact when you have, for example, two name nodes, right? And the actual process is run on one of them.
Yeah.
How do you achieve high availability when that node goes down, or the primary goes down?
Yes, no. The question was about if a primary name node goes down, how does the secondary name node is started? So you have no primary name node in HA setup. You have two name nodes. They are can be switched in between. They have a state. The state is active or passive, and active or standby. Sorry. And the standby node is replicating all the stuff, and the active one is actually containing the meta store, maintaining the meta store. If the active goes down, Then there's a different daemon, I forgot about that. That's a zookeeper face fencing controller. It switches from the name node from the first one to the second one and promotes them to the active one. And every Hadoop client can discover the switching of the name node, and it retries it because we have a different naming scheme. It's called HDFS/cluster, and it actually tries round robin all these cluster nodes. But that's built into Hadoop.
Okay.
You said you required offline installation. How
Yeah.
did you package the binaries and how did you make them available on the cluster?
With Debian packages.
Okay.
Yeah.
Great. And
Apt-get install.
how did you push them to the cluster when you deployed them?
We have a repository of our own. In fact, we have several repositories of our own, which are configured at the clients, and we are doing apt-get install.
Okay.
This is the normal installation. So, BigTop is packaged as a repository, as it's the convenience artifacts we are calling it. And if you're going to the BigTop homepage, you will find the release, and you can add in the release repository to your favorite Linux distribution, and yum install, zipper install. No, zipper install isn't supported, but apt-get install is supported.